Before we were talking about exponents, well, we're going to kind of go backwards. We're going to do the opposite of an exponent. So we're going to talk about square roots. So the reason that we have square roots, first of all, write square roots, where it came about is if you have a square and it's 3 inches by 3 inches, then you know 3 times 3 is 9. So we could put 3 times 3 is 9. But maybe we wanted to go backwards and go, well, what number times itself gives me 9? So I want to go back this way. So the way you write that is the square root of 9. You're asking yourself, what number times itself equals the number under the radical? And the radical is just the little square root sign. Okay, so looking at that, we could say that the square root of 9 is 3 because 3 times 3 gives me 9. Let's look at how we write it in the symbols. So we have this symbol out here, and it's called the square root symbol, or you can call it the radical symbol. And then in the middle is a number, and you call that the radicand. So you have your radical and your radicand. Now, let's look at how we do this. So one of the rules for when you do the square root is if b squared equals a, so let's say I did 4 squared equals 16, so 4 would be my b and 16 would be my a, then b, so this number 4, is a square root of a. So if I did square root of 16, I know that it's going to equal this number right here. Let's look at some examples. So I have the square root of 44, or 144. So I ask myself, what number times itself gives me 144? And the answer to that is 12. Actually, there's two answers because negative 12 times negative 12 also gives you 144. But let's look at that example on C. On B, we have square root of 144, but the opposite of it. So first go here and go, okay, what's the square root of 144? 12. But what number is the opposite of 12? Negative 12. Now let's look at this. You have a plus and a minus, a positive and a negative. So first you say, okay, the square root of 144 is 12. I'm going to have a positive 12 as my answer, and also a negative 12 as my answer. So let's look at another example. Before I get into that example, though, let's talk about perfect squares. So perfect squares are numbers that when you do the square root of them, they give you a whole number. So for example, if I have the square root of 1, I know that 1 times 1 gives me 1. And the square root of 4 is 2 because 2 times 2 gives me 4. And then the square root of 9 is 3 because 3 times 3 gives me 9. And I have the square root of 16, and that would be 4. So any number that gives you a whole number when you do the square root is considered a perfect square. So 1 is a perfect square, 4 is 9, 16. The square root of 2 is not, because it's going to give you a decimal when you put it into your calculator. Let's look at evaluating terms that are under a radical expression. So you have b squared minus 4ac, and it's all the square root of that. So the first thing you do is just ignore your square root first and just look at, okay, they told me that a equals 1, b equals negative 2, and c equals negative 3. So you're just going to plug them into your values. So I know that b is negative 2, so I'm going to go negative 2, put a parentheses around it, put my little squared, minus 4 times whatever a is, so 1, times c, which is a negative 3. And then I'll put my square root. I'm still kind of ignoring it though. I'm not worried about that yet. So negative 2 times negative 2 is positive 4. And then I have negative 4 times 1 is negative 4. And negative 4 times negative 3 is positive 12. So I have a plus 12 here. So I have the square root of 4 plus 12. I'm going to simplify that even further. The square root of 16. And what's the square root of 16? it's 4. So your answer would be 4. The reason I bring up this is later on we're going to deal with this b squared minus 4ac when we get into something called quadratic equations. So it's good to know how to do it now. All right, the last example is evaluating expressions that give you numbers and you have a plus and a minus. So the way to do this is, first, if it's a fraction, let's start on the numerator, let's say. So I have 1 plus and minus the square root of 3. I know that's not a perfect square. So if we use a calculator and we round it to the nearest hundredth, what you do is you put the number in and then you hit square root. And what you're going to get is you're going to the square root of 3 is going to be, let's pull it up on here. I'll get our calculator up. So I do a calculator. And I'm going to put my 3 and I'm going to do the square root right here. So it gives me 1.732 blah 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 blah. I want to round to the nearest hundredth, so I'm going to have 1.73. So I'm going to write down here 1 plus or minus 1.73 over 4. And I know all of you are going, what, plus or minus? I don't understand. Well, what you do is you break it into two equations. So the first one, or I'm sorry, expressions, is 1 plus 1.73, which would be 2.73 divided by 4. And then you have 1 minus 1.73, which is going to be 0.73 divided by 4. So I'm going to pull out my calculator again. So I think I need to pull it up on here. And I'm going to do both of those problems. So I do 2.73 divided by 4, and I get 0.6825. And if I'm rounding to the nearest hundredth, it's going to be 0.68. Now I'm going to do the other one. So I have 0.73 divided by 4. And that's going to give me, let me look at it again, 0.1825. So to the nearest hundredth would be 0.18. And I changed colors. Okay, so looking at that, let's make sure that we did everything correctly. And it looks like we did. So we have two answers. And that's only because we have a plus and a minus right here, because you're going to be adding and you're also going to be subtracting. But first you want to simplify your square root and then do the math. Okay, so that's basic square roots. We're going to get a little more in depth on our next lesson.